Hello, everyone. My name is Bernard Gagnon. I'm the Senior Manager Engineering for the Power Space and VR Systems and Simulation for L3HARRIS. Today's presentation will be on extended reality for asset familiarization and training. So today's outline will be first about L3HARRIS. So I'll present the company and more specifically on the power systems and simulation business. And I will follow on with project examples for power and non-power business, and then provide some takeaways. So first, our organization is based in Montreal, Canada. We're part of a larger organization based in Melbourne, Florida, called L3HARRIS Technologies. We focus on naval, power, space businesses, and we provide automation, simulation, and training solutions and products. So the power systems product portfolio consists of first newcomers and classroom training technologies. We also provide full scope operator training simulators. We also have simulation assisted engineering used for plan design, development, and deployment. We also have 3D visualization and immersion solutions, which I'll cover in that presentation. We also have technology-enabled training services. So we're able to provide the facility, the simulators, all the technology to perform training and actually operate the facility. We also provide plant control computer solutions for can-do plants. So back to extended reality. So we started our journey more than 20 years ago. In the early 30s, it was very expensive to come up with VR trainers, but luckily the gaming industry was booming, so it was able to allow platforms to reduce the cost of these XR trainers. So we also deployed training solutions using 3D in many industries for power and non-power. And the presentation will cover some few project examples. So first, let's start by our first projects that we did, which was regarding space station robotics operation training. So that VR simulator was for mission planning and operation training. It provides a high fidelity 3D model with dynamic simulation, which also includes real-time contact dynamics. The astronauts are actually certified on that simulator, and they are more than 100 international astronauts that were trained on that simulator since 1997. So it was really challenging during that day to perform such a trainer. And because of the limited computing and graphics capability in the early 90s, but it was really proven to be an excellent solution, and it was working very well for all those years. Just to provide an overview of the capabilities of the trainer. So you see the 3D environment that allows the astronauts to operate the Canadian arm, to perform all operations. And you see the detail of the simulation that's provided. Different perspectives, so you're able to see different camera views, really being able to simulate the real context of what the astronauts would face. And then we develop also surgical procedure training. So it's a VR simulator for surgical planning and procedure training. So it's for minimally invasive endoscopic procedures training. It provides high fidelity physiological response. It also provides haptic feedback, which is more realistic. And it was very challenging due to the model tissue dynamics in real time. So again, just show an example of the tool. So the user had the ability to select the instruments and then perform the procedure. A very realistic environment. You can feel the tissue. able to manipulate the instrument to actually perform the operation. Okay, and then for ship operations and maintenance training, we have a product called Synthetic Maintenance Trainer. This is targeted at maintenance personnel, and it has various modes. So first, it has the tutorial mode, which will have a framework a little bit more to encapsulate what the user or the maintainer will do. There's also a practice or a free play mode, which allow to do all kinds of operations in free play, and also examination mode to evaluate the student capabilities. So the solution provides realistic 3D environment to practice maintenance tasks. So either understanding and following procedures, also troubleshooting all kinds of errors or failures, replacing some equipments. And as I mentioned, there's also tutorials and play mode associated with it. So the simulation of application-specific instruments and equipment, so the power distribution. So if you power off or on an equipment, you will see the effect. So there is actual model providing the right effect and really the behavior of the various components. Same thing for communications status. So if we remove an Ethernet cable, then it will disrupt the communication. And all managed within an LMS, a learning management system, to track the student's performance. Again, just a short video providing the context and how the tool works. So in tutorial mode, as we can see, it guides the student to be able to, in that case, to open the panel and then basically guide the student to refer to the wiring diagram to make sure they understand what they're about to do, and then after that, making sure in that case to remove that fuse and basically perform the right operation to replace the equipment. So it highlights the faulty module, which is, you saw the red LED light that was providing the failed component, and then by using the right equipment, you're able to use either multimeters or other equipment to verify the voltage at the IO level. And then it concludes the demonstration for this. And then for nuclear power plants, we started with the 3D worlds of complex nuclear island systems. Coupled with process simulation. So attached to a full scope simulator, we were able to attach a 3D model, and that provides really a good training value for the student to really understand what's happening in the plant. And there's also, we applied the same technology for individual plant components for fundamental knowledge. So basically being able to understand really the basic components, how they work, how they operate, and so on. So, and then full-scale process simulator integrated immersive simulators to enhance worker knowledge, perform actions on complex equipment, conceptualize and design plant and different plant outage activities and decommission end of life. So it's very, very useful for various activities. So for fundamental trainings, the learning modules allows you to show the student really to understand how the various components work. So from a library of objects, the user can select the desired component, and then through a 3D animation, it describes the behavior of the object itself with the principle of operations. And then we also provide different modes. So the other modes would be major components, which will really allow the student to understand how the different components are made. So all the different components and parts of the component. In that case, it's a valve. And then for system training, we have a learning simulator, which allows to present the containment building with all the components, so the reactor core, the reactor coolant system, with the steam generators, to really look at the different components, how they're made in a static mode or more equipment view that we call it. And then after that, we can attach it to a live simulation to really see how the plant is behaving in certain situation, either normal or abnormal. So attached to a live simulation, you're able to follow all those process values and really see what's happening inside the model, or what would actually happen in the real plant. So you have different views to be able to see what's happening. So you can drill down to the reactor core. You can also look at the spent fuel pool and also the containment building. And then if we go one step further, we can even simulate in a 3D immersive environment a gigawatt class nuclear power unit with all the different systems. And then basically for that example, what we did is that we use it in different display environments. So either with VR, headgear, or other large displays. We also provide the user the capability to change the 3D environment. It's very realistic, so it's not cartoon-like. It has all of the textures required to provide a really as close as possible to life environment. It also allows multiple users to be part of that environment. You're able to access some metadata attached to the different systems and components inside the plant, which is a very powerful tool, and many other features for either radiation and with also the capability to record scenario and playback and so on, which is very useful for all the different applications that you see on the left side. So either through animated systems, you have a 3D flyover training scenarios, which I'll come back in a minute. Very powerful tool. So just an example of the different graphics that we have. So the entire nuclear power plant unit data was ingested, retaining the metadata. It accessed to over 85,000 individual components, and basically a massive amount of data that had to be ingested inside the environment, providing a high realism 3D interactive environment, which also provide, as I mentioned earlier, virtual radiation dose model. So for the rad workers to walk inside the plant, and depending on the shielding or the material between the source of radiation, a model that would also calculate the various doses. So multiple users training, so up to 10 operators, male or female, that would be represented as avatars inside the environment, that would allow them to move, walk, climb the stairs or the ladders in the environment, very realistic, being able to select the personal protective equipment and measurement inspection tools. And we also provided a virtual glass model to pretty much provide a good description visually of how the various components work. But then we also had system isolation. So from a view inside the plant, you're able to isolate the system and then basically drill down to the different data associated to that system to better understand how it works. And we also have a scenario editor that's used for operation and emergency preparedness and maintenance training. So it's a graphical environment that allows the user to actually prepare all the various scenarios. So to configure the navigation paths and the environment that the student or the maintainer or the operator would be facing in real life. And then we also provided a NORCID immersive environment, which is the equivalent of a providing a true depth perception of headset-free environment. So it's pretty much a room that you walk in and you're using reflective reality that allows the user to really see the 3D environment, but in a very realistic environment. So that environment is provided in 3 formats for 2 users, up to 6 users, or 15 users if you have more people collaborate together, which is very powerful and as close as possible to life. So the immersive nuclear power plant simulator example, so for the benefits, so first for design support, it allows to catch drawing errors, raising awareness, establishing real as-built conditions, and it's a very good platform for design modification. So when you need to perform a change inside the plant, you really see what's happening when you replace components and see where the components fit through different doors, and that's very powerful. And for operational effectiveness, the platform is there to improve the personal training. It's very efficient for work planning and job briefs and many other environment, and it's all integrated. That 3D environment is integrated with the customer IT systems for the better understanding of the equipment lineups to support the maintenance activities. So that's another very good benefit of this. So in conclusion, from space to medical to naval to power, we have a lot of expertise and experience, and we're leveraging the various needs of the different businesses to come up with a very, very good product that can meet all of the various needs. So the 3D visualization and extended reality is definitely penetrating the energy sector, and it's here to stay. So it's used for design, support, and training for operational and maintenance effectiveness. So the important part also is that it all runs on commercial off-the-shelf equipment, and also the applications for technology growing and only limited by your imagination. So we can expand on currently what we have to provide better training and also maintenance support. Thank you for your attention.